Oh, hello there. You're back. I assume that's because you enjoyed the last video. You're here for more information. Well, today we want to talk about something called measures of variability. Now, previously we've talked about measures of central tendency, how to tell whether or not a value is typical in a data set. But measures of central tendency are not the whole story. Let's consider two different probability and statistics classes. We have class A and class B. Now, class A takes a test, and everybody in the class gets a 75. Class B takes that same test, and half the people get a 100, and the other half get a 50. If you calculate the average test score for these two classes both have an average test score of 75. But these are very different classes. And so there's stuff lost by only looking at what is a typical value. Another aspect of a data set that we're interested in is how much variability is there? How much discrepancy between data points? For class A, where everybody gets the same score, we have very little variability. In class B, where we get half get 100 and half get 50, there's some more variability. But how do we define how much variability there is in a data set? Well, just like previously, there's more than one way to answer that question. And we're going to talk about two of those in this video, and we're going to talk about the most common one in a separate video. So the first way of talking about variability is to just talk about the range. And the range is very simple to calculate. You take the largest value and you subtract the smallest value. That's it. And so for class A, we have class A. The largest value is a 75, and the smallest value is also a 75. So we get a range of 0, very low variability. Whereas for class B, the largest value is going to be 100, and the smallest value is going to be a 50. So we get a range of 50. So it shows that there's more variability in class B. But range has a pretty big issue with outliers. So outliers are values that are unusually big or unusually small for a data set. And if you have a value that's unusually big or unusually small, then those are generally going to be either your largest or your smallest value. And they're going to show up in this calculation. So for example, if one of these people in class B that got a 100 happened to be in class A, then all of a sudden we have everybody gets a 75 except for one, and so our largest value becomes a 100. And then all of a sudden class A has a range of 25 instead of 0, but we've only added one extra point. So we want to ask, how can we deal with this in a way that isn't so sensitive to outliers? And so that's where the interquartile range comes in. To talk about the interquartile range, we're going to have to talk about quartiles. So quartiles. Instead of talking about class A and class B, let's work with a different data set. So let's consider a data set where we have the following values: 9, 6, 5, 13, 11, 17, 2, 1, 15, and so here's the values that we want to work with. And so to talk about quartiles, the first thing we need to talk about is the median. And so if you remember from the previous video, right, how do we calculate the median? Well, we start by taking our data set and we put it in order from smallest to largest. So in this case, this becomes 1, 2, 3, 5, 6, 9, 11, 13, 15, 17. And then we look at how many values we have. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. And so we have an even number of values, which means we're going to have two middle values. In this case, value 5 and 6 in order 1, 2, 3, 4, 5, 6. So that's going to be 6 and 9. And so we take the mean of that. So 6 plus 9 divided by 2 is equal to 15 divided by 2, which is equal to 7.5. So this is our median. And what's nice about the median is that it splits our data exactly in half. Right? By definition, half of our data is below this and half of our data is above that. So if we look at our data on a line, then where we have the median, we have 50% of our data over here, and we have 50% of our data over here. So our lower 50% in this case consists of 1, 2, 3, 5, and 6. And our upper 50% is 9, 11, 13, 15, and 17. And so the word quartile, kind of reminds us of the word quarter, is 25%. And so we can get that by splitting each of these 50% again. So we're going to take the median of each of the halves that we got from the median. So for our bottom 50%, we have 1, 2, 3, 4, 5 data points. So we have an odd number of data points, which means we actually have a middle value. In this case, it's the third one. And so this value right here, we're going to call the lower quartile. Or this is also sometimes referred to as the first quartile. And so that is going to be the value 3. For our upper 50%, we again have 5 data points. These should match. And in that case, the third value is 13. And so that's going to be our upper quartile. Or third quartile. And so what these values do is if we then put in the lower quartile and the upper quartile, we've now split our data set into, this is the bottom half of the bottom 50 or the bottom 25%. This is the lower middle 25%, the upper middle 25%, and the top 25%. So between the median and the upper and lower quartile, we've broken our data into 25% chunks. And so now we can ask, what is the interquartile range? And the interquartile range abbreviated IQR is just the upper quartile minus the lower quartile. And so in this case, it's 13 minus 3, or 10. And why is this range better than just the regular range? And the reason is this tells us the range from the bottom 25% to the top 25%. Which means what we do is we say we're going to throw out the bottom quarter of the data, and we're going to throw out the bottom or the top quarter of the data. And then we're going to ask, what's the range of the middle 50%? And by doing that, we eliminate outliers. If we have an outlier that's too small, it's going to be in the bottom 25%. If we have an outlier that's too big, it's going to be in the top 25%. And so this gives us an idea of the range of our data for the middle, the part that isn't unusual. And because there's differences in calculating these ranges, you have to make sure that if you're comparing two data sets, you don't compare the interquartile range of one data set to the range of the other. We got to compare apples to apples or oranges to oranges. Otherwise, things get bananas. And we don't want that. So look forward to the next video where we talk about the third type of measure of variation, one that's significantly more complicated, but is significantly more popular.